Now we're going to look at the pH and pOH scales. This is another way to express whether a solution is acidic or basic. If the pH is less than 7, it's considered an acidic solution. If it's greater than 7, it's basic. And if it's equal to 7, it's neutral. If you own a swimming pool or your parents have a swimming pool, you probably know that the pH needs to be checked. And the pH in the swimming pool is important. And you may have seen some sort of a little chart like this that might have had different colors on it, but whole numbers and acidic and basic. So here's pH. pH runs from 0 to 14. And let's see what the next slide says. Well, this is not really that helpful. What pH is a logarithmic function. So pH is the negative log of the hydronium ion concentration. Because those hydronium ion concentrations are, like 5 times 10 to the minus 3 and 7.25 times 10 to the minus 13. And they're small numbers, and they're over about 14 orders of magnitude. And so they're difficult to grasp, graph, and they're hard to write. And so a logarithm will condense that into nicer numbers. So here we're taking the base 10 logarithm of the hydrogen ion concentration and then changing the sign of it. So negative log does not mean anti-log. It means take the log and change the sign. pHs are almost always positive. If the hydronium ion concentration is 10 to the minus 4, the log of that number is the exponent. The base 10 logarithm finds the exponent on the 10. So 10 to the minus 4, you take the log of it, and if you have your calculator, get it out. Put in 1 EE4 minus and press the log button. And it'll tell you minus 4. The pH is plus 4 because we stuck that minus sign in there to make everything positive. 10 to the minus third. The log of that is minus 3. Change the sign and we get 3. 10 to the minus 2. The log of 10 to the minus 2 is minus 2. Change the sign, we get plus 2. So here, if we represent each circle as 10 to the minus 4th moles per liter of hydrogen ion concentration, when the concentration changes from 10 to the minus 4 to 10 to the minus 3, it increases by a factor of 10. And when it goes from minus 3 to minus 2, it increases by a factor of 10. This is 100 times more concentrated than this one. The logarithm goes from 4 to 3. 1 unit change in pH is a 10-fold change in concentration. The Richter scale for earthquakes is also a logarithmic scale. And so an earthquake that's magnitude 7 is 10 times worse than one that's magnitude 6. And so that's how pH is as well. Any questions? pH is the negative log of the hydronium ion concentration. And then note to myself, explain logarithms. Thankfully, we only have to deal with base 10 logarithms. I already explained a little bit, but let's just make a little table, and this will be x, and this will be the log of x. So if x is 10, 10 is the same as 10 to the first power. The log of 10 is 1. The log of 100, that's the same as 10 squared, is 2. The log of 10 to the 14th is what? 14. So when we're looking at factors of 10, taking the base 10 logarithm is very, very easy. It's just the exponent. If the exponent is negative, then the log is negative. So 10 to the minus 7, the logarithm is minus 7. The pH for this one would be plus 7 because of this negative sign. All of these hydronium and hydroxide ion concentrations are less than 1. And so the logarithm of that concentration is going to be negative. And negative numbers can just be a pain to deal with. So we made the formula to be negative log so that all the pHs would come out to be positive. Any questions? Calculate the pH of each solution and indicate whether the solution is acidic or basic. So that pH equation is something that you definitely need to memorize. So pH equals the negative log of the hydronium ion concentration. You're going to use your calculator to do this. So the first one, 9.5 times 10 to the minus 9. Well, you enter that number into your calculator, 9.5 EE minus 9, and press the log button. Now, some calculators you have to press log first and then put the number in. You have to figure out how to talk to yours. And then I'm going to press the change sign button to make that number positive. And so the pH for this is negative log of 9.5 times 10 to the minus 9 is going to be equal to 8.02. pH does not have a unit that we write. Any questions? How about the next one? 6.1 times 10 to the minus 3rd is the hydrogen ion concentration, hydronium ion concentration. What's the pH? Anybody? 2.21. Now, I'm not going to test you on this, but I do want to tell you about sig figs and logarithms. The pH here, this 8 is related to the exponent, and the digits after the decimal point are related to the significant figures in this number. Because if the hydrogen ion concentration, let's get a different color here. If the hydrogen ion concentration is 9.5 times 10 to the minus 7 molar, the pH will be 6.02. Because this exponent is different from this by 2 orders of magnitude, a factor of 100, and so this digit before the decimal point goes down by 2. Check me. 9.5 EE 7 minus log, change the sign, 6.02. The O2 is where the significant figures come in. The 6 amounts to placeholding zeros. If the hydronium ion concentration is 6.1 times 10 to the minus 12. The pH will be 11.21. This number comes from that exponent. It's not exactly the same, it's one less. The digits after the decimal point come from this. If this is the same, like in these two numbers, 6.1, the decimal places are the same. All that's different here is the exponents. So you don't have to know that, but just in case you're wondering why it appears that I'm throwing in extra significant figures, that's what it is. Any questions about calculating pH? It's just using the formula and using your calculator. What if we have the pH and we need to know what the hydronium ion concentration is? Well, some of you will be interested in this and some of you will not, but I'm going to do it anyway. This is the pH equation. This right here is the result, and I'm going to show you how I got that. We're going to rearrange this equation and solve for H3O+, which I'm not going to expect you guys to do. But I'm going to multiply both sides by -1 to move the negative over here. And then I need to get rid of log. Log is a function. You can't divide by a function. You can only undo the function. So the opposite of log is 10 to the x. So what I do is I take 10 to the x of both sides. So then I get 10 to the minus pH and 10 to the power of the log of the hydronium ion concentration. 10 to the x and log cancel each other out. And we get 10 to the minus pH is equal to the hydronium ion concentration. That's another very useful equation. So on your calculator, most likely on the same button that has log on it, is 10 to the x. And I told you not to use that for scientific notation. That is the anti-log. And we're going to use it for these sorts of calculations. If you're given the pH, you use the 10 to the x button. You make it a negative, use the 10 to the x button, and that'll give you the hydronium ion concentration. Calculate the hydronium ion concentration for a solution with a pH of 8.37. Well, the hydronium ion concentration will equal 10 to the minus pH. So 10 to the negative 8.37. That's kind of a strange looking number. Exponents do not have to be integers. On my calculator, I put the number in first, 8.37. I change the sign to make it negative, and then I need the second function, 10 to the x, and my calculator shows me the answer. Some calculators, you have to press 10 to the x first and then put in the exponent. So I'm getting 4.3 times 10 to the minus 9, and then I'll put the unit molarity back on it. Any questions? P is actually a function. You can have pH. Remember I said that we often use hydronium ion and hydrogen ion equivalently. A lot of times you'll see it as the log of the hydrogen ion concentration. POH is the log of the hydroxide ion concentration. You could also have P calcium ion, which would be the negative log of the calcium ion concentration. And there's a very cool relationship between the pH and the POH. I'm blanking. Absolutely blanking. Oh, I know. Okay. 10 to the minus 14, sorry, is equal to the hydronium ion concentration times the hydroxide ion concentration. I left off the 1 times the. If I take the logarithm of both sides, The logarithm of 10 to the minus 14 would then be the logarithm of these two numbers. When you have logarithms of numbers that are multiplied, then you add them. So the logarithm of H3O plus, logarithm of OH minus. The log of 10 to the minus 14 is minus 14. And this, I'm going to multiply both of these by -1 as well. So that's going to be a negative, and that's going to be a negative. And this is going to be a negative. So now, oops, negative 14. The negative log of the hydronium ion concentration, that's pH, right? Plus, the negative log of the hydroxide ion concentration is the pOH. The pH plus the pOH always add up to 14. I don't expect you to necessarily even appreciate the beauty of that, but I feel compelled to show it to you anyway. Just what's in the box. The pOH plus the pH always adds up to 14. Okay, using pOH, calculate the hydroxide ion concentration for a solution with a pOH of 4.25. This is just like doing the pH calculation. So hydroxide ion concentration is going to equal 10 to the negative pOH, just like the hydronium ion concentration equaled 10 to the minus pH. So this is going to be 10 to the minus 4.25, 4.25 negative, 10 to the x. The hydronium ion the hydroxide ion concentration equals 5.6 times 10 to the minus 5. If you don't have your calculator in lecture, you should go home and try these and make sure that you're communicating correctly with your calculator and getting the same answer. Or send me a text and tell me I screwed up, because I've been doing that a lot lately.